let's do an example with a ship, shall we? Okay, so our ship, don't worry, it's not like it's going to do that every time I say ship. Okay, well, too good. Okay, so our ship leaves port on a bearing of 140 and sails 3 kilometers. It then turns and sails 2 kilometers on a bearing of 300 degrees. Find the distance and bearing of the ship from the port. Okay, so somewhere along our line, we just need to make sense of, it says here, what are bearings and how do bearings work? Now, just out of interest, has anyone worked with bearings in any sense? Maybe you did it in physics, maybe you've been on a ship somewhere and seen this idea. Has anyone? Okay, well, fascinated to see. I wish I knew now as I'm making the video. Maybe we could draw on your knowledge. But bearings work differently. We used to kind of doing this and going, well, 140 degrees from the pause on that idea because bearings work differently to the Cartesian plane. Bearing means that you're starting at a certain point, like at port, and if you went due north, then you would be going 0 degrees. That would be your bearing. And then they measured clockwise around. So if you went, perfectly to the right, you would have a bearing, then you'd change your bearing to 90 degrees. And if you went, the other way, that would be 180, 270. So from here, if we kind of added in the rest of our compass, where we had east, south, and I think west is over there, seem right? And we went 140 degrees. Well, if we went round to this far, we'd be at 90 degrees. So we're going another 50 degrees, and that would mean that we've gone in that direction for, let's put our number here, 3 kilometers. So that's the idea, that it's 3 kilometers, where this angle here is 140 degrees. So just maybe out of interest, this angle over here, what's that angle equal to then? Well, that mystery angle there would be 40 degrees, right? Just angles on a straight line. We had that, we've got that's 140 degrees, so we've got 40 degrees. May or may not be useful, but that kind of thinking of maybe we're going to draw a triangle then over here, and 40 degrees would be more useful than that angle there. Then maybe we think exterior angle of a triangle, etc. Okay, so there's the first part, and then I'm just going to draw the other one maybe a bit quicker without that explanation. That is, once this ship is sailing in this direction, it's sailing now in that direction and gone 3 k's, and then it turns and sails 2 kilometers on a bearing of 300. So from that point there, which I'm going to redraw over here, and we'll redraw one nice big diagram shortly, and that is that one there, which is probably behind me. There we go, it's a bit better. Now, remember that just for reference, we've got north here, it goes 300 degrees. So now it's going to go 300, that would be 180, 270, 300 degrees. 3,000, that's a bit much, 300 degrees. And it's now going to go in that direction, and it's going to go for 2 kilometers. Okay, so that's what it's going to do. What we need to check are the bearing. So it says the distance and the bearing of the port of the ship from port, so from its original port. So I'm going to leave you for a second and give you half a chance just to try and draw a diagram of those two parts, of these parts over here. So combine those two into one diagram, and then hit OK when you want to come back. Okay, so you got something down. I'm going to scroll down and give myself nice bit of space here to draw this in, and let me just move out of the way. Okay, so my diagram looks something like this. We start off at port, and I'm going to call port point P for port. Good, eh? And this ship to start with is going to go off in this direction, and I'm going to go along for 3 kilometers. Now remember what we said was this all relates to this. I'm going to see if I can do it like this and go, well, from port, if we drew our compass over here and this was north, then this angle that goes around to here, that must be 140 degrees. Okay, so that looks good so far. That's kind of what we had in the first part. Now, when we down here, it says, okay, well, the ship turned and then went 2 kilometers at a bearing of 300 degrees. So if at that point, I'm just going to draw, and I'm just drawing this a bit lighter because our diagram's going to get nice and messy soon enough. So if that's north now, and hopefully that's kind of popping up clear enough for now. Is that looking good? Yeah, I'm just keeping half an eye on how this is all looking. And now we said, well, from there, let's go along in a blue direction. Seems good. And we're going to go across in that direction, but let's go fully like this. We're going to go across like that for 2 kilometers. Not too bad for my scale, I think, if I do say so myself. And this now, we said, well, this bearing, remember that whole thing there is 300 degrees, not 360. Saying 300, let's make that neat. Okay, so if you need to check your diagram, tweak it if you need to, but that's kind of the diagram that I get when I draw the whole thing together. And to kind of finish off the whole thing, what we need to work out, let's do this in black to say, so the ship is now sitting over here. Here's our ship. And our ship, we're seeing how far away is it from port. So let's call this distance D. So there's our ship sitting in the middle of the sea. It's gone 3 k's, 2 k's. How far and what bearing is it? So our last question is going to be, what's this angle all the way around to the ship? That's what we need to find out, D and that angle. Okay, so it's looking okay so far. Feels like we don't know enough just yet because, we've got this triangle in the middle here. So let's just have our triangle here for reference, like that, and like that, and like that. We know this is 3, this is 2, and this is D. Now, if we had some angles, then we could start using our sine rule and cos rule, right? Right? Yeah, okay. So if we had our angles, we could do that. So we need some sort of angles, like this one here. Well, then we'd probably have our final answer. This one, or maybe this one here. I'm just putting kind of different dots because they're not the same. So now we need to work with those. So maybe just at this stage, do you have any way of working out? And let's call this point down here where the ship moved. I'm going to call this, I think, T over here. So let's just put this like this. So this is point T, because T is where it's turned. So if I'm going to call this angle T, this one inside the triangle angle S, and this one inside the triangle angle P, just any ideas at the moment of how you're going to find T, S, or P inside the triangle? Cool, I'm hoping you've had, some ideas here of, working with this 140, working with this 300. So let's just see here, because there are going to be a few ways you could maybe think through this. And that is, maybe as a hint, what we've got here is, you could think of this line being parallel to this line. So now perhaps there are some alternate angles. We could think that this line up here is parallel to this line up here. Again, maybe some alternate angles now finding their way in. Maybe you just worked out some of these other angles. Well, if that's 140 and this is 90, then this angle here is 50. This whole angle over here was 50. That whole angle there is 40. We worked that out before. Okay, well, 50. Well, alternate angles, that's this whole angle over here is 50. Well, and again, so as I said, you may have done this slightly differently. I'm just playing around and trying to encourage you, play around with these angles and play, well, if this whole thing is 300, that's 270 up to there. So we've got another 30. That doesn't quite make sense. My parallel lines don't quite make sense. What's wrong with my diagram here? This whole angle here is 300, right? So what was our 40 was in here? Oh, this isn't. Oh, that is 50 over there. That's fine. 90, 50, 40. Okay, so maybe let's just rewind. That one doesn't seem so good. That's because that whole angle there is 50. I see. Okay, no pause on that. That whole angle there is 50. Now 300 gets you up to the blue line. So we've got 300, so each of these is 90. So where I'm working around is there's 0 degrees, there's 90 degrees, there's 180, there's 270. So if we've gone 300 around, then this angle over here, well, that must be 30 degrees, right? So kind of there's our thinking. So there's 30 degrees in here. Let's do that in yellow. So there's 30. This part over here must be 20 inside the diagram then. So this part is 20 degrees. Cool. Feels like we got somewhere. But maybe you did it with alternate angles. I know when I've done this actual particular question, I did it completely differently. I worked with my alternate angles this way around, and I got a 50 degrees. I got a 40 degrees over here. Kind of makes sense. So there's what we got so far. So I'm going to remove these kind of bits of working that we had. And for now, let's work on the fact that this angle over here is 20 degrees we've got. There's our 20 degrees. Okay, now that we've got two sides and an included angle, so just focusing on this diagram over here, two sides and an included angle, are we going to use sine rule or cos rule? Well, I definitely think the cos rule is going to work for us because, well, our cos rule means that 2 squared plus 3 squared equals, so d squared, let's write this down, right? Let's write this down. D squared, that was in black actually, d squared equals 2 squared plus 3 squared minus, and then we go 2 times 2, 3 times cos of the angle in between, right? Well, there we go. That will help us find what d is straight away. Isn't that quite helpful? So let's run through that. Let's grab our beloved calculator out and go, okay, so d squared is all of that. So let's square root that. 2 squared plus 3 squared minus 2, 3 cos 20. Yep, what do you get? 1,31. Let's go to 1 decimal place. So d equals 1,3 kilometers. Okay, so it's an involved question. It certainly is. There's quite a lot, and this is why we're taking our time just working through it nice and slowly. So fairly involved question that we've drawn our diagram. We've kind of, out of the diagram, picked out our triangle, worked out our angle. As I say, I kind of hope that you've played around with all of these angles in between. And so what we've got now is d is 1.3. Okay, great stuff. So if d is 1.3, let's add that into our diagram, 1.3. We definitely need to work out what this angle here on top is to help us work out this bearing. So what we know so far is that whole angle is 40 degrees. So if we drew a line, let's see what's going to make sense here. If we drew a line like that, this whole angle here is 40 degrees. So if we can work out what this little angle is, we can work out what the bearing is. Or alternatively, you might want to look at it this way. Ooh, not get rid of that side of the triangle. And say that we know that, where do we go in yellow? That this angle here is 50 degrees. So therefore, if we can work out this angle inside the triangle, our bearing is going to be, that was in black down there, our bearing is just going to be, here's our kind of our red line over there. It's going to be the 50 degrees plus that angle plus 90 degrees. So we can work out our bearing. But the most important thing for now is just to think, how are you going to work out this angle over here that I'm just going to call angle P for simplicity? So how are you going to work out angle P now that you know these three things and this angle in our triangle? Okay, well, perhaps you're still scratching your head a bit, and that's also a bit fine. But perhaps our sine rule is going to help us. Maybe not, but our sine rule means that if we've got an angle and a side, angle side, then those things go together nicely. So I'm going to do this, and I'm going to take that diagram, and put it in the wrong place, and put it over here and say, working from that diagram, we're going to say that we want this angle P. So if we go sine P over the side that's opposite it is going to equal sine 20 degrees over the side that's opposite that. One thing we don't know, and you've done quite a few of these questions now. So into the calculator it goes, and we get, where's my calculator hiding here? And we go sine P. So if on that side we've got sine 20 divided by 1.3 times by 2. That's what sine P is. So if that's what sine P is, so if sine P equals 0.52, etc., etc., how are we going to work out what P is and what is P? Well, we'll go shift sine of that, and we get 31.7. I'm going to go P equals 32 degrees. Closest degree is definitely going to be close enough. So that's 32 degrees. Now, I've redrawn this picture a few times. I think it does make sense that you just working in this exact same diagram. I'm just trying to show my thinking of this diagram's getting quite complicated. So we've worked out that that was 32 degrees, right? 32 degrees. So we've got that that's 32 degrees. And so therefore we can work out that whole bearing. So I think if you've got one nice big diagram that you can concentrate on, great stuff. But I've just snipped out little bits so we can see that. And I want to reinforce, it's an involved question. So now what we've got is, if that's 90, that's 50, that's 32. Therefore our bearing from the top is, well, we can add all those things together. So I think we said, let's find a spot for it, because I want to keep that diagram there. So our bearing is 90 degrees, that's that 90, plus we need to add the 50 degrees, because that's that 50, and then plus the 32 degrees, and we get 32, I think, 172 degrees. I'm worried that I was out by a decimal place somewhere other, which is quite possible. But let's see, 31.74, yeah, that's right. So there we go. There's our bearing, which is that going all the way around. Take a pause, re-look through that, come back to this diagram if you need to, look through what you've put down as well, and just work your way steadily through each bit. We've kind of got it into something manageable, but it is quite something, and you may feel like you've just inhaled a helium balloon.
And you're just going like, what did we just do? But you know what, while you're thinking about that, I think you can make it maths.
Make it maths.